the basic structure. Yeah. All right. So we go a little faster. Select from where block. Yeah. All right. The first block, select block. Attribute list. Yeah. Comma separated. Then from block, it's a table list. Comma separated. Okay. Yeah. But later, this from block, we can use several tables, and we can combine the tables through different join operation. The join operation, okay? Different type of join operation. So this from block could be very complicated, all right? So then the last block, the where block, condition, yeah. So most of the time we need to spend our most time on this where clause. Yeah. All right. Then projection attributes. Yeah. So here I need to explain this projection attributes. What do we mean projection? Yeah. We borrow this concept from math. Yeah. In math, geometry, you know projection, right? Yeah. But here, when we do the database query, so we have a situation similar to our math projection. Yeah, so here I need to explain the meaning of that. So what's that? The select clause specifies the attribute whose values are to be retrieved. When you retrieve, because usually in a table we have a list of attributes. Yeah. And many times we do not need to list all the attributes, right? Yeah, many times. Many times we only need to select some of the attributes, not all. Yeah. Then part of the attributes in the list, so we call it projection. Yeah. So you have a whole list. Then what's the meaning of projection? Part of the elements in your list. That's the projection. Yeah. So here, let me use a simple diagram to explain that concept. Yeah. In geometry, we know the meaning of projection is, suppose you have a, rod like that. Okay, the sunlight, this direction. Okay. Then the projection, this line segment, that's the projection. Okay? Yeah. And the length of the projection segment is shorter, less or equal to the original length, right? Yeah? Yeah. Yeah. The maximum, the same as the original line length of the original, rod length. Yeah, but many times, most of the times, shorter than the, length of the original pole. Yeah. All right. Here we use this idea. Yeah. In our situation, the full length means the whole list, the whole attribute list. Yeah. But we don't need all the attributes, right? Yeah. We only select some of the attributes we are interested and put there. So the projection means some of the attributes in the list. Okay? Yeah. Subset. You can understand as a subset, okay, of the elements in the attribute list. Yeah. But the subset, you need to add one more requirement. Yeah. Yeah. Subset, we know Because when we talk about subset, our elements are not ordered, unordered in the subset, right? But in projection concept, we need to add order information. So here, order property is important. So our projection is an ordered sublist. Yeah. So you can understand in this way. Yeah. Ordered sublist. Yeah. So we know actually the elements in a list are ordered, right? Yeah. When we say list, what's the meaning of list? Elements in a list are ordered. Yeah. So here you need to, make sure you need to consider the order information in the projection. Okay? All right. Yeah. Yeah. Selection condition. Yeah. Where clause specify Boolean condition. Remember, Boolean 3-value logic. 3-value logic, not 2-value logic. So later we need to understand that 3, especially that unknown value. Yeah. True, false, we are familiar with. But for unknown, that special case, we need to understand. Yeah. Must be true for any tuple. Yeah. So here you can see, how do you determine one particular row should be selected? Yeah. When you evaluate the Boolean expression on that particular row or tuple, you get a true, then selected. Okay? Yeah. So here, that's simple, right? True for any tuple. Yeah. The value true. Yeah. All right. But let me say in this way. Yeah. Let me say in this way. Yeah. So be careful. Okay. All right. The where clause specify Boolean condition. Yeah. So let me say it this way. If we evaluate a Boolean expression on a tuple, and we get a value that is not false, should we select it? Not a false. Should we select it? Not a false. Okay? Yeah? Yeah. No. Yeah. Because unknown, not a false, it could be unknown, right? Yeah. So if it's unknown, it's not true. So we cannot select. Right? Yeah? So here you can see, yeah, when you work on 3-value logic, you should be careful. Yeah. If it's not false, it could be unknown. If it's unknown, it's not true, right? Yeah. So this condition is not satisfied. It's not true. So you cannot select it. See? Yeah. Yeah. All right. Yeah. Then, oh, sorry. Yeah. Yeah. Retrieval, select statement. Yeah. Result return. It should be a multi-set of tuples. Duplicate values are allowed. Multi-set. Yeah. Okay. All right. Tuples can appear more than once. Yeah. All right. Then the question, our understanding of next question. How do we deal with the duplicate tuples in certain operations? Because later we need to do some type of operations on our tables. Yeah. Then you have duplicate tuples, then you need to follow some rules. Yeah. So we will get there. All right. Reasons not eliminating duplicate tuples. Yeah. So people may ask, we just eliminate. Yeah. Then, because based on your business requirements, sometimes you cannot eliminate duplicate tuples. No, business requirements, sometimes we need duplicate tuples. Yeah. All right. The user may want to see duplicate tuples in the result of a query. Yeah? Yeah. Some important business meaning people need to see. Yeah. Duplicate elimination is an expensive operation. Yes, so here, this is another property you need to think about. Think about how to remove duplicate rows. Yeah. Right? Suppose you have an array of elements containing duplicate values. Now you need to write a program, okay? Find some algorithm to remove the duplicate values. How do you do it? Think about that question. When the array size is large, small, especially when the array size is large, how to do it? Relatively small, then, the efficiency may not be that important. But when the array size is huge, think about that. Do you want to sort the array? Sorting. Because if you sort the array, then it's easy to remove duplicate elements, right? First you sort it. But the sorting operation is very expensive, right? Sorting is relatively slow. Especially when you sort a large array. How fast it is. When you sort a large array. That could be very slow, right? So for that reason, remove duplicates for a large array. It's a very expensive operation. Okay? Think about that. All right. That factor you need to consider. Okay, all right. One way to implement it is to sort the tuples first and then eliminate duplicates. Okay? One way to do it. But this way, when we use this way, it should be for an array whose size is not too large. Otherwise, sorting is too slow. Sorting too slow. Okay? But you may want to ask, if the array size is large, can you find a better algorithm? Okay? For arrays of large size. So sometimes you may need to remove the duplicates, right? Sometimes. There is a faster operation than the sorting, hashing. Okay? The hashing algorithm. I hope you know a little bit. In algorithm class, so you learn this hashing technique. Okay? Hashing. Faster than sorting. Why faster? If we use the algorithm asymptotic notation, we know how fast. Hashing asymptotic big O of n. Suppose the size is n. Okay? The size, you have n rows, n tuples. The size is n. But sorting, big O of n log n. Big O of n log n. Okay? But here I say for relatively large array sizes, because if the array size is relatively small, if you apply the hashing, you need to do a lot of work, preparation, overhead. Yeah, because hashing, you need to, do the mapping, right? So those things, the hash functions, when you do that, that's the overhead part. Yeah. So relatively small, you don't want to do this way. Yeah. Because you need to consider the, overhead factor. Yeah, a lot of overhead for this technique. So, yeah. But for large array sizes, then worth, because the overhead you pay, worth the investment, okay, because your gain is much better, much higher than that overhead part, okay. Yeah. All right, so that's the, this duplicate elimination question. Yeah. Then, in SQL, how do we remove? We use this distinct keyword. Yeah. Because in SQL, most of the time, our array size is not that large, right? Yeah. Most of the time, our table size not too large. Yeah. So, So we can, just do it. So we add this distinct keyword, select distinct, then the result table, you won't have the duplicate tuples. Yeah. Yeah. Removed. Yeah. Yeah. Automatically. Yeah. All right. Yeah. So when an aggregate function is applied to tuples, in most cases we do not want to eliminate. Yes. Now I need to talk about this point. Yeah. Yeah. All right. Yeah. Because later we will spend a lot of time to study some aggregate functions. Yeah. So that's count function, average function, sum, maximum, minimum. So those aggregate functions. Yeah. When you do that, do you want to remove the duplicates first? Yeah. For some of the aggregate, for example, for maximum, minimum, do you need to remove duplicates? You don't need, right? Yeah. You keep the duplicate rows. You can still apply the maximum function, right? You can still apply the minimum function. Yeah. Yeah. So that's the meaning here. Because if you want to remove the duplicates, you spend a lot of time. Yeah. Then you apply the aggregate function, you get the same result. Yeah. So that's the reason. Yeah. For the performance consideration, so then we do not remove. Yeah. Yeah. That's the meaning of this statement. D.2, remove duplicate tuples. Here I just show you some examples. Yeah. So very simple examples. Yeah. Select distinct syntax. Yeah. You add that distinct keyword. Yeah. Then, the remaining normal. Yeah. Syntax, select distinct, column 1, comma, column 2, comma, dot, and so on. Yeah. Yeah. Then from table, condition. Yeah. Yeah. Example here. Yeah. Select. Here I use our company database. Okay. Yeah. So here, by default, so this company, if I do not say anything, company database, it is our default database. Okay. Yeah. 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 So our questions default, question based on this default database. Yeah. All right. From this dependent table, now we want to, so here, this is a projection, okay? ESSN, comma, sex. Yeah, so that projection, okay? 2 fields, 2 columns, yeah. That. Distinct, yeah. We want to remove duplicates. Yeah, think about if one employee has 2 children with the same sex, right? 2 children with the same sex. Then you will have duplicate rows. Okay? Yeah. Yeah. But here, because we only want to see, yeah, if one employee has dependent of one of the genders, yeah. So we want to remove the duplicates, yeah. Distinct, yeah. All right. All right. Yeah. So the query result, what do you see? Yeah. Yeah. Just like this. Yeah. When we apply on the dependent table. Yeah. All right. One thing here I want to mention, yeah, because every semester I can see sometimes one, sometimes two or more students. Yeah. Because when I give you the query questions, I ask you to write a query statement. I do not need you to give me the query result. Okay? You don't need to include the query result. Yeah. But some students, copy the query result. Okay? Yeah. Don't need. The reason is simple. Because when the data changes, your result will be changed, right? Yeah, the data could change. Yeah, yeah. So that's why I ask you to write the query statement, not the return result. Yeah, because that result could change, right? Yeah, when the data is different, dynamic data. Think about we're working on dynamic data. The data change all the time. So when you run the business, the data changes all the time, right? Yeah. So we don't want to see the, yeah, yeah. So, yeah. Be careful of that. Yeah, because sometimes some students, even one thing that's I saw a few students did that. They gave me the query result by their observation, not running the query statement, using their eyes to find the result, then send it to me. Then they use a lot of time, because when you use eyes, then you copy. It took a lot of time, but you can get 0 point, because I cannot give you any point there. I want you to write the query, SQL query statements. Okay? Yeah. Not the result. Yeah? So I saw some students, yeah, not recent semesters, a few years ago. Yeah. Okay? Yeah. So that's why I emphasize, yeah, do it in the right way. Yeah. All right. The data here just for reference. Okay? The data here, yeah, we look at the data just for reference. Yeah. Yeah. All right. D.3, join two tables. This is the biggest topic in our homework assignment number 2. In our homework assignment, we want to practice the table join two tables. Yeah, let me see how much time I have. Yeah, because I want to, I try my best to complete. Yeah. All right. So I should have. Yeah. It's possible to complete this topic. Yeah. So then you can start working on, table join operations. Yeah. Join two tables. Yeah. After you. Yeah. So let's practice join. Yeah. Because then 3, 4. Same idea. Yeah. So let's understand how to join two tables. Yeah. All right. Question. Let's use one simple example to look at the table join. Okay. All right. Retrieve the name and address of all employees who work for the research department. Yeah. Let's try to write the query statement for this question. Okay. Yeah. Here you can see. Yeah. What are those related tables? Yeah. Yeah. Address, names for all employees. First, you need to use employee table. Yeah. Then second, who work on research department. There is a department, second table. So you need to use these two tables. Yeah. So you should combine the data from these two tables through some special relationship. Okay? Yeah. All right. So let's look at two tables are used. Yeah, these two tables. Yeah. All right. They are related. First, we need to understand. So what is the relationship between these two tables? In the employee table, there is a column, department number, because each employee, we need to know which department that employee belongs to. Yeah. So there is a department number column. Yeah. So in employee table. Yeah. All right. So that is the column name. We call it DNO. Yeah. Department number. Yeah. So here in the department table, we have that department number column, but we call it D number. Yeah. So here in these two different tables, the same concept, right? Yeah, the same thing. Yeah. Same thing, department number, the same thing. But people intentionally, they call the same object two different names in two different tables. See? In the employee table, yeah, the database designer. So here, let's think about the database designer intentionally use a different name for the department number. This number. In the department table, the designer intentionally used this D number. Yeah. The reason is simple. Yeah. Because people, they do not want to get confused, right? Think about if you call the same name, it's very easy to get confused. Yeah. Let's imagine we call it the same name, D number. Then when you talk about D number, then people may ask, your D number comes from which table, right? Department table or employee table? Then you need to explain, right? Yeah. But here you call different names. When you say D number, it must come from department table. When you call DNO, it must come from employee table. Yeah, things like that. Okay. So at the design stage, you need to, consider these little things. Yeah. All right. Then, the most important part, the join condition. When you join two tables, you need to specify the join condition, how to join two tables. Yeah. All right? Yeah. Actually, this can be used as a join condition. Yeah. All right. It combines two tuples, one from the first table and one from the second, whenever their values are equal. So here, yeah, because when you join, the join condition like that, okay, yeah, when the values are equal, department number equal from two different tables, then in that situation, you should join the tuples from two tables to form a new longer tuple. Okay? New longer tuple. All right? Yeah. I will elaborate. Okay? Yeah. This point is relatively hard to understand, but I will spend a lot of time to elaborate the meaning of this table join. Okay? Join two tuples, when the values are the same. Yeah, I will use a diagram to show you. Okay, so you can see, in a very clear way. Yeah. Yeah. Then look at the statement. Yeah. Select first name, last name, address. Okay, this part easy. From also easy. We just list the names of two tables. Yeah. Yeah. Actually, table name not necessarily capital, right? Yeah, so we know. Because they are not keywords, right? Yeah, not necessary. Yeah, yes. So here. Where then, this we call the selection condition. This is not join condition, okay? Yeah, so this is the selection condition, the first equality. Then the second is the join condition. The second is the join condition. So you join two tables. Then you select. After you join two tables, so you join the table first. Yeah. So you apply this join condition first. After you apply join condition, the result, return the result, then you apply the selection condition. Second. Then you get a result. Yeah. Okay? Yeah. Yeah. So what do you see? Yeah. So the results for the requirement. Yeah. But you want to see better, yeah, because you want to see how the result of the two joint tables formed, right? You want to see that. Yeah. So, yeah, I will show you. All right. But before I show you that, before I show you that, we need to understand math concept, table join, because here we borrow another concept from math set theory, okay? Another concept, yeah. Join two sets. Join two sets. Yeah. There is a similar operation in math, set theory. In set theory, okay, how do you join two sets? Yeah. There is a existing operation in math. Yeah. So we borrow that operation. Okay, all right. If more than one table is specified in the from clause and there is no where clause, yeah. So here, to understand the table join, we want to divide it into several steps. Step 1, 2, 3, 4. So we understand gradually through those steps. Yeah. All right. And here we need to borrow concept from math, cross product concept. Cross product. All possible tuples combination. So what is the cross product? Let me review a little bit. Yeah. From math, people also call Cartesian product. Let's recall our, discrete math. Cartesian product, the meaning of that. Yeah. All right. So in set theory, a Cartesian product is a mathematical operation that returns a set from multiple sets. Yeah. In which way? Yeah. Which way from multiple sets? Yeah. Yeah. Here is an example. A cross B, Cartesian product. Okay. Yeah. All right. So now this new set, we form this A cross B set using the elements from both sets, A set and the B set, both sets. Yeah. All right. So the new elements, we use tuple. Right? So this two tuple. Okay. Yeah. Two A comma B. Yeah. Parenthesis, it's a tuple, right? Two tuple. Two components. The first component, you pick the elements from A set. The second component, you pick one of the elements from the second set. In this way, you put together, you form a new set. We call it Cartesian product or cross product. That's the definition of the Cartesian product. That's the way we join two sets. And now we will use the same idea. We join two tables. Okay, yeah. All right. Cardinality concept, cardinality. Yeah. How many elements in the Cartesian product? So that's the cardinality. Okay, yeah, that concept. Yeah. We use vertical bar, just like absolute value. Here the meaning is the number of elements in a set. Yeah. So here it does not mean the absolute value. Yeah. Same notation, but meaning is different. Meaning, we call it cardinality of the set. Yeah. All right. So the cardinality of the Cartesian product equals the product of the cardinalities of the two sets. You multiply, yeah, together. Okay, yeah. All right. Yeah. Extend it to database there. Now we need to use this concept the same way we want to understand it. Table join operation. Yeah. All right. Yeah. Yeah. Table, but here the table we treat it as a multiset. Table we treat it as a multiset. That means duplicate rows are allowed. Multiset. So it's different from math. In math, we don't have the multiset concept. Okay, we do not have the multiset concept. Yeah. But in our computer science, yeah, we have the multiset concept. Yeah. All right. Apply Cartesian product on multisets. Then you need to specify how to deal with the duplicate rows, right? Duplicate rows. How do you how does the DBMS handle the duplicate rows when you apply the Cartesian product? Yeah. All right. Later. Yeah. So we will talk about that. Yeah. Later. Now, yeah. The last thing. Yeah. I want before the class end, I want to show you this table join operation in 4 steps. Digest the table join operation in 4 steps. Yeah. The standard approach, yeah. Process. 1, 2, 3, 4. Yeah. All right. But very simple 4 steps. Yeah. When we join 2 tables, join 2 tables with cross product without considering the join. So the first step, remove the where clause. Okay? Do not include the where clause. Join 2 tables. Yeah. The way you join cross product, that's the step 1. Yeah. Because that's the simplest step. Okay? Yeah. Without applying any condition. No condition. Just join 2 tables. Yeah. By the Cartesian product, cross product. Wait. Yeah. All right. Yeah. This step always works. Well, right? Always works. Yeah. Here, let me show you a simple example. All right? All right. So you have, let's assume you have 2 tables. The first table I use capital T, second table I use capital S. Okay? All right. The first table T, so you have a list of tuples T1, T2, Tn. Right? Yeah. That's the first table. The second table you have a list of tuples in S table, S1, S2, ... Sm, right? Yeah. All right. Then this first step, you just force new tuple in the Cartesian product at Ti, Sj, right? Yeah. Ti, you select any one of the tuples in T table. Yeah. Sj, you select arbitrary one tuple in S table. Then you get a new tuple in the joined table. You can always do that. Yeah. You can always do. That's the step 1. All right. Step 2, you apply the join condition. Yeah, because after that, you need to use a join condition to eliminate all those rows that return the value not true, right? Return the value true. Eliminate not true value. Eliminate. Yeah. True value, you keep. Okay? you keep those rows with true value on the join condition. When you apply join condition, get a true value, then you keep them. Yeah. That's step number 2. Okay, all right. Use the imaginary tuple variable. Yeah, here there is a concept called imaginary tuple variable. Okay, to go through all the tuples. Yeah. Now, think about when we use a for loop, we need to use a counter variable, right? There is a counter variable. Go through all the iterations. Here, similar to that counter variable. Here we imagine when we go through all the rows in a table, in our mind, we consider there is an imaginary tuple variable. Every time we work on the current tuple, okay? So one after another, yeah. So, going through all the tuples in the table, yeah. Just like a for loop, okay? Yeah. So the imaginary tuple variable, go through all the tuples, yeah. Yeah. All right. Only select those tuples that satisfy the join condition, okay? Every time when you work on the current tuple, you check the join condition. If it's true, you select it. If it's not true, could be false, could be unknown, right? If it's not true, yeah, could be false, unknown, you eliminate it. Yeah. Throw away. Yeah. Okay, that's the step number 2. Yeah. Step number 3, apply select condition. You have select condition, right? Yeah. The department name is research. That's in our previous example. That's the selection condition. So you apply. So you eliminate more rows. Yeah. That's step number 3. Okay. All right. Step number 4. We have last step. Yeah. 1, 2, 3, 4. The last step, step number 4, projection. Remember the projection. Yeah. 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 On the result table. Make projection when necessary, yeah? Because you do not need to include all the attributes from the join table, right? Yeah. You don't need all the attributes. You only need selected attributes from the joined table, so you need to do the last step, projection step. Yeah. In our previous question, our projection, because we want the first name, we want the last name, and we want address. Those 3 attributes. We only need to keep the information for those 3 attributes. So that's the projection. Okay? Yeah. Yeah. So these 4 steps, you complete a table join operation, joining 2 tables. Yeah. The standard process. Yeah. Okay? All right. Yeah. Now, after you understand so this is a theoretical understanding. Yeah. Yeah. Theoretical understanding. Yeah. Pretty abstract. You need to use your imagination to understand. Right? So our next step, we want to use a concrete example. So we want to use the concrete data to help us understand this table join operation in 4 steps. Yeah. So when we apply this concrete example, we want to go through these 4 steps, one by one, to make you see clearly. Yeah. Because inside the DBMS, yeah, DBMS goes through these 4 steps. Now, we cannot see it, right? Yeah, we cannot see it. Yeah. We just get the result, yeah, table join result. Yeah. But DBMS follows strictly these 4 steps to complete a table join. Yeah. All right, let me show you. Yeah. Yeah, tuple variable. Before that, yeah, let's understand tuple variable a little bit. Okay. Yeah. You just use your experience of for loop. Yeah. So you have a lot of experience using for loop. Yeah. Similar to that for loop. Yeah. Here. Yeah. Think of an implicit tuple variable or iterator in the SQL query. Yeah. You cannot see it. You can only imagine. Yeah. In a for loop, you can see it, right? Counter variable, iterator, you can see it. Yeah. But here in SQL, you cannot see it. You can only imagine that special implicit object. That's why we call it implicit object. Yeah. Not explicit. Yeah. Looping over each individual tuple in the table. Yeah. So you need to go through from the beginning to the end. Okay, one by one each time. Yeah. Yeah. Going through. Yeah. So through your imagination. Yeah. Evaluating the condition in the where clause. Yeah. For every current iteration, current tuple, then you apply your where clause, the condition on it, and look at true or false, okay, or unknown. Yeah. Boolean value. Yeah. Then you make a decision. You want to select this current tuple or eliminate it. Yeah. Only those tuples that satisfy the condition are selected. Yeah. Yeah. Satisfy, we know the true value. Yeah. Satisfy that condition. Selected. All right. All right. Then the last step, D.5, illustration using an example. Yeah. Using our company database. Yeah. I select the same two tables, employee table, department table. Okay? Yeah. But this time I use the concrete data to show you the detail. Yeah. Intermediate results after each step you want to see it. Yeah. All right, let me see how much time. Yeah, I have at least 10 minutes. That should be enough. Yeah. 10, 12 minutes. Yeah, I can complete this final example. Yeah. Although at the beginning we lost 15. Yeah, actually, let's say 10 minutes. Yeah, because if we do not have that problem, usually we in our preparation we lose a few minutes, right? Yeah. But this time we lost relatively more minutes. Yeah. Yeah. So we can complete this part D. Yeah. We use last 10 minutes. We use this example. We complete it. Yeah. So let's start this example. Yeah. All right. Yeah. So here we want to understand. We want to see the intermediate results when we run this SQL command. Okay? Yeah. We assume this is SQL command. So DBMS needs to run the SQL command. Yeah. But we want to see intermediate results of those 4 steps. Step 1 was the intermediate result. 2, 3, 4. Okay? Final result. Yeah. All right. Let me draw 2 tables. The first table, yeah, our employee table, yeah, containing 40 employees, yeah, based on our data, 40 rows in our employee table. Yeah. So here, I cannot copy everything, right? I just, draw some basic structure here. Yeah. Second table, department, 6 departments. Yeah. Yeah. So 2 tables we want to draw. Okay? All right. First, let me ask the question. When we join these 2 tables by the Cartesian product, okay, you understand the meaning of Cartesian product. What are the total number of rows in the Cartesian product? You use these 2 numbers, 40 from first table, 6 from second table. After we do the Cartesian product, join. 240. Yeah, product of these 2 numbers. 240. Yeah, direct product. Cardinality, remember the formula? Cardinality definition, product of the cardinality of 2 tables. Yeah, good. All right, so here for the first table we use little s for the tuples, S1 through S40, 40 tuples. Yeah. The second table we use little t's, yeah, T1 through T6, 6 tuples, the second table. Yeah. All right. Then the first step, employee cross department, Cartesian product, okay? Without where condition. Yeah. We ignore the where clause. Now you can see the first part of the columns we just copy the column from the first table, okay? The second part, we copy the columns from the second table. That's simple, okay? Yeah, all right. So then, when we list those rows, we use the, combination in this way, okay? Yeah, S1, comma T1, S1, comma T, and so on, okay? Yeah, so follow some order. Yeah, yeah. The last one is S40, comma T6. Yeah, so you list them, all the possible tuples you can get from these two tables. Yeah, that's the first step. Yeah, you can see, from S1, the first part, S part, you have 10 columns. 10 columns from the first table, right? Yeah. The second part, you have 4 columns from the second table. So the total 14 columns, okay? So when you do the Cartesian product, you get a joined table with 14 columns. 240 rows, that's the table, okay? That's the structure, all right, yeah. That's step 1. Step 2, so this time, at the beginning of the step 2, we have 240, 14 tuples, okay? 14 tuples, you know the meaning. Yeah, each tuple, okay, has 14 components. Yeah. All right. Yeah. Now you apply joint condition. This is joint condition. D node equals D number. Yeah. Because you have a D node column, right? And you have a department column. When the values, for the same row, the values here, the values there happens to be the same, you select it. Yeah, so that's, you apply the joint condition, okay? Then you get a 14 tuples. So you eliminate 200 tuples. Yeah. Yeah. Only 40 of them satisfy this condition, okay? Yeah, so after this step, you get a 14 tuples. Yeah. Before you apply selection condition, step 3, selection condition, right? Yeah. Now, step 3, selection condition. Now, this time you check if the D name value, so there should be some D name value. Oh, sorry, D name is here, not there, not in that input. The D name here, you check, if its value equals the research. If it equals that, you select it, okay? Yeah, the selection condition. So after this step, you only get 14 tuples. Only 4 left, all right? Yeah, 4 of them satisfy this condition. All right, last step, projection, because you don't need all 14 columns, right? You don't need all 14 columns. So the last step, you do projection. You only need 3 of the attributes in that 14 total attributes. Yeah. First name, last name, address. Yeah. Okay? So you do projection, you get your result is 4 3 tuples. Yeah. 4 rows, each row is a 3 tuple. How about that? Yeah. Yeah. So this example, you see the whole picture of table join. Okay? Yeah. So
what makes it go from 40 to 4? Like, are we dividing it by 10 or?
Not divided by, you eliminate 36. Eliminate, because 36 of the 40, their D values different from research. So you cross out, okay? Yeah, department, could be sales department, could be, other department, right? There, human resource department, other different values you eliminate. 36 of them, you eliminate them. So it's not some division thing. Okay? Yeah. Yeah. Only 4 employees in the research department. Okay? Then you only keep the 4 employees in the research department. Yeah. That's the, idea. Okay? Yeah? Yeah, use this example to understand table join. Okay? Yeah. All right? Yeah? Step by step. Then you feel comfortable. Okay? Because you understand the logic. Yeah. You understand internal logic. So you feel more comfortable. You follow the logic when you work on table join. Okay? All right. Yeah. So then the data, yeah. Here just for reference, okay? Yeah. In your answer, I don't need this, okay? Don't give me this in your answer. Yeah. Here, for reference. Yeah. Yeah. All right. Understanding purpose. Yeah. Okay. All right. Yeah. So, let me see if I have. Yeah. So So that's all I have. Okay. Yeah. But after that, yeah, because after that, I need to give you 10 questions, 5 from Northwind, 5 from company, okay? Mainly about table join, all right? Yeah, yeah. At least 4 questions for table join, yeah, 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 yeah. For each part, 4 of 5 table join. Another one also 4 of 5 table join, yeah. Okay, and I hope before you start, if you want to see more examples, you can. Table join section in MySQL tutorial, W3 schools. Okay, W3 schools, there is a table join section. Yeah, so you study that tutorial. There are several examples. So you work on, practice those examples, understand first, before you start. Yeah, because you need some experience, right? Yeah, you need some your own experience before you can work on our homework questions. Okay? Yeah. Yeah. W3 schools. Yeah. All right. Yeah.